Hello ladies and gentlemen, welcome back. This is a tutorial video for students who are in Algebra 2 Goal 4 during our coronication. We are revisiting the quadratic formula, mostly because most of my students are starting to get into the 40 and 50% and they're using the quadratic formula, and certain topics become a little bit annoying just because they're not quite sure how does this logic again. So what we're going to be doing is we're going to be looking at these topics right here: quadratic formula, exact answers, complex roots. Special note on that one, complex numbers I'm going to be talking about, fingers crossed, in the next video. And then one of the easiest probably topics involving the quadratic formula is talking about the discriminant, and one of the topics in particular is a DSA question, so we want to talk about those. First things first, a quick review of the quadratic formula. If you know your A, your B, and your C, the quadratic formula is x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So first things first, we want to get used to using the quadratic formula, so let's get ourselves down to brass tacks. Click, click, zoom in, there we go. Okay, I might not have given myself enough room, we'll see how we do. But what we're looking to do here, label first, obviously, so that's my A, because that's my x squared, that's my B, since it's my x, and that's my C. And since it's exact answers, just so you know, the title tends to give away the game. What this means is that you're going to have a square root in your answer. That's what having exact answers means. If it said, not exact answers or decimal answers, what that means is that you would be approximating and you have like 2.643 or something like that. So quadratic formula, x equals opposite b plus, or excuse me, I need to actually be using my numbers. So opposite b plus or minus square root of b squared minus 4ac all over 2a. So it's a little bit messy because my handwriting is garbage, but now we are all set and we can start simplifying. So it's opposite 4 plus or minus. What is the square root of 4? What is 4 squared? 16 minus, or nope, there's a negative here and a negative here, so that's a positive. 4 times 2 is 8. 8 times 3 is 24 all over 4, okay? So that is negative 4 plus or minus 16 and 24 is 40, and then all of that is over 4. Now from here I have a question for my students. This 40 can be simplified. What I want to know, you guys let me know, is can you input this as is into the answer box, and will the software take it? If not, we'll play it safe. 40 breaks down, that is 4 times 10. And again, if you need a refresher for that, let's go up here for a second. We're looking at 40, right? Root 40 that we're trying to simplify. 40, what is my biggest number? So anything above 49 is too big. So what I'm doing is I'm taking 40 quickly in my head because I am the human calculator, and I'm dividing it by all of my perfect squares. So 36, no. 25, God, no. 16 is close. 16 times 2 is 32. No, it's not going to work. Okay. 3 divided by, or 3, sure. 40 divided by 9, no. 40 divided by 4, yes. That is 4 times 10. That's my perfect square number. When you're simplifying your root, that's always what you want to do. So what is root 4? That's 2. Can you do root 10? No. So we just leave it as 2 root 10. And that's what we're doing down here. So if it's 2 root 10, it'll be negative 4 plus or minus 2 root 10 all over 4. So again, this is where, because I don't have the software immediately in front of me, and as a teacher I can't always input answers, this is the lazy way, this is the accurate way. And whether they allow you to be lazy in the software is one giant question mark. You guys let me know. So next problem, I want to do a couple just to make sure we're comfortable with the format. So there's my A, there's my B, there's my C. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c. That's a little bit neater. All over 2a. So that gives us opposite 9 plus or minus 9 squared is 81, minus 4 times 2 is 8, 8 times 5 is 40, over, nope, over 2 times 2, which is 4. 81 minus 40 is 41 over 4. And this is where being a human calculator is kind of awesome, because I happen to know that 41 is a prime number, meaning nothing divides into it, which means I'm done. This is as far as I can go. All right, one more, make sure we're comfortable. There's our A, there's our B, there's our C. So x equals opposite B plus or minus square root of B squared minus 4AC all over 2A. Alright, so that's negative 5 plus or minus 5 squared is 25. Double negative is a positive. 4 times 4 is 16. 16 times 2 is 32. And again, if math facts are not your thing, you can use a calculator for this. It's just that as a human calculator, I can do these computations pretty quickly in my head. Plus or minus 25 plus 32 is 57. 57 over 8. And again, math brain, I happen to know that that is prime 57, which means there's no way I can break it down like at all. And wait, it's divisible by 3. Yeah, but it doesn't have a perfect square factor. So there's our answer. Next one, A, B, and C. And now again, if it's blank, that means your invisible number is a 1. So x equals opposite B plus or minus square root of B squared minus 4AC all over 2A. I kid you not, back in the pencil paper days, a quiz or a test would be coming and I can't give them the formula. All I would do is start humming. And then you could see the kids going, oh. Anyway, enough nostalgia. 1 squared is 1. Double negative is a positive. 4 times 2 is 8. 8 times 9 is 72 all over 4. So that's negative 1 plus or minus root 73 all over 4. And then there is our answer, and that's what goes in the answer box. Okay. So that is computer. What are you doing, computer? There we go. All right. So exact answers is now done. The next one I want to talk about are the discriminants, because they're a little bit easier, so we're going to start with that. So I think it's this one. Yep. Discriminant of a quadratic equation. Right there. From the quadratic equation, there's your discriminant. B squared minus 4AC. And here's what we're really looking for. This here you want in your notes for reference. If you're going to have two solutions, it's positive number. If it is 0, then it's going to have one, or if it's 0, then it's going to have one solution. If there's no solutions, that means you're going to have a negative number. And that makes sense because you'd be square rooting a negative number, and that can't be a negative number, Ms. Dubois, not negative 1, just a negative number. And you can't fundamentally do that unless you talk about imaginary numbers, and that's a later deal. So compute the value of the discriminant. So we're doing the b squared minus 4ac, and then the number of real solutions. So we're doing both of these things. We're doing our b squared minus 4ac equals something, and then our number of solutions is going to equal something. So b squared, so 20 squared minus 4 times a times c. That's what we're looking for. So 20 squared, again, perfect square numbers. What's 20 squared? Right here is going to be 400. So 400, negative times a negative is a positive, positive times a negative is a negative, 4 times 25 is 100, 100 times 4 is 400, equals 0. So that's our discriminant, and since it's 0, how many solutions are there? 1. Like, really, that's kind of it. That's all you're doing for discriminant. So let's see here. Next one, calculate the discriminant. So b squared minus 4ac. B squared is 8, so 8 squared minus 4 times negative 2 times negative 3. So that's going to be 64. Double negative is a positive, times a negative again is a subtraction. 4 times 2 is 8. 8 times 3 is 24. So subtract that, and that's going to be 40 for our discriminant. That's a positive number, so the number of solutions is 2. And you start to realize, wait, this actually isn't that bad. I low-key kind of know what I'm doing because none of the math here is overtly hard. So Couple more. I want to make sure you're comfortable with these, and I find having about 3 to 4 examples tends to be the sweet spot. So b squared minus 4ac. So 8 squared, wait, is that the same thing? Gosh darn this software when I want to do screen grabs. Okay, you get the point. One more, apparently, instead of 2 more. So b squared, so negative 7 squared minus 4 times a times c. Now I'm seeing into the future, and I already know that my number of solutions is going to be 2, but that's my assumption for now. Let's see if we're right. Negative 7 times negative 7 is positive 49. 4 times 4 is 16. 16 times 2 is 36. 49 minus 36 is 13. So there's my discriminant. And then the number of solutions, Ms. Dubois, label your work, is 2. 13 is a positive number, so that's why our discriminant looks as it is. And since it's positive, it's going to be 2 solutions. Okay, so far so good. But what happens then if you have a parameter? The horror, miss, there's a variable there. What's it doing? What in the name of schnitzel? Insert curse word here. Except when you actually bother to read this, they have everything you need, and then they give you exactly what you're setting it to. So we know this. The whole point is b squared minus 4ac. That part makes sense. And then they tell you 2 real solutions. What does 2 real solutions mean? Greater than 0. Oh, so then all I'm doing is filling in and solving? Yes. Yes, that's all you're doing. So b squared is negative 2 squared minus 4 times 5 times negative j greater than 0. So again, that negative is attached to the j. You want to be careful with it. Make sure that you're including whatever sign it is that you're doing. Obviously, if it's positive, you don't need to write anything, but those negative signs, man, they kill people. Give me a second while I take a drink of water. All right, so negative 2 squared is 4. Double negative is a positive. 4 times 5 is 20. J greater than 0. Minus 4. Again, we're solving j because j needs to be isolated. So let's see here. That will be 20j greater than negative 4. Divide by 20. Divide by 20. And if you're a fraction whiz like Ms. Dubois, you know that that's negative 1/5. Done. That's really, again, much like with finding a discriminant, the work is actually not all that hard. The only difference here is that you're setting it equal or unequal, as the case may be, to something, and then you're going through the effort of solving. You do need to remember a little bit about your inequalities. So if we're looking at this one, for example, b squared, so negative 4 squared minus 4 times a times c, 3k. And then we want it to be no real solution, so we need it to be a negative number less than 0. So 16 plus 4 times 3 is 12. 12 times 8 is 96 less than 0. Oops, k, 96k less than 0. We're going to practice our social distancing and isolate that poor k. So subtract 16 minus 16. Let's see here, 96k less than negative 16. Divide by 96, divide by 96. I'm going to pretend I can do math in my head at stupid o'clock in the morning. I think that's 1/6. Again, for those of you with your calculators, you can get the more accurate number. I'm just doing this really fast in my head. Keep in mind, just as a reminder, hashtag reminder. I can do that, right, in a video? When you're dividing by a negative number, your inequality flips. I have a couple more examples. We'll see if we can, oh, I have one more example. So let's see here. So we have b squared minus 4ac has 2 real solutions, so greater than 0. All right, let's see here. So it is negative 2 squared minus 4 times a times c greater than 0. No, this one doesn't do it. All right, I'm going to change this problem just a little bit. I'm going to change that to positive 2 just to illustrate a point, okay? Nice. Shrink my brush size. All right, so let's go through the efforts of going through this. So we have 2 squared, which is 4. 4 times 6 is 24. 24 doubled is 48k greater than 0. Minus 4, negative 48k greater than negative 4. And this is what I was talking about by my little reminder. If I divide by negative 48, if I divide by negative 48, what happens to your inequality? It flips. That's the thing you need to remember. So k, instead of being greater than, it now has to be less than our 1/12. All right, so that's 2 topics now that have been taken care of. We've done discriminant, and we've done discriminant with a parameter. And the one with a parameter, again, I emphasize, it's a DSA question. You want to be careful with it. Next one, solving a quadratic equation with complex roots. Before we do, keep in mind, you're going to have the letter I in your answer, and if you have not done, and we're back. Sorry about that. My poor computer is starting to overclock a little bit. So, complex roots. Where was I? Okay, so complex roots, what that means is we're going to have somewhere the root of a negative number. That's fundamentally impossible, so we're going to do, instead, to make it a little bit visually more appealing, is we're going to use the letter I. So that's what we're mentally preparing ourselves for. There is a whole family of topics that deals with the letter of I in Chapter 4. If you're in the upper percentiles, you've usually already done them, and I'll have a video on them forthcoming because, good Lord, there are so many topics in Goal 4. Why am I still working on it? But getting back to this, it's quadratic formula again, and we're coming in knowing that we're going to have the root of a negative number, and we're not going to let that confuse us. So let me rewrite that. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So much easier than typing. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. So again, if you have a blank number or a blank variable, your invisible coefficient is going to be a 1. So now we start to simplify. Negative 6 plus or minus, what is 6 squared? That is 36. Double negative is a positive. Oh, okay. So this is a maybe. Ha! Because not all of them apparently are going to give this to you. Double negative is a positive. 4 times 1 times 2 is 8. All over 2 times 1, which is 2. So negative 6 plus or minus, what is 36 plus 8? 44 over 2. 44 is 4 times 11. So negative 6 plus or minus 2 root 11 all over 2. I'm starting to go a little bit fast here. You can see that I'm not explaining or justifying every single step that I'm making, because by this point these are skills that you've been using across like multiple topics. I've been talking about the quadratic formula since the start of the communication. I've been simplifying radicals. I keep pointing you guys to my list of perfect squares 1 through 20. By this point, you should be comfortable enough that you, even if you don't necessarily see what I'm doing immediately at a glance, you understand, oh wait, I can do it, I can do it. And again, the beauty of having a video format is that you can actually hit pause and process what I did. Shock of all shocks. Let's try this one. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. So simplify that. So negative 7 plus or minus 7 squared is 49. 4 times 3 is 12. 12 times 7 is... My brain skittered to a halt. Oh my god, what is 12 times 7? 84, right? And you can already tell there's our negative number. Over 14. What is 84 minus 49? I can't do that and write at the same time. 84 minus 49. Negative 35. And there's the problem. That negative. That darn negative. So what happens is when you have... Let me pull this off to the side because I haven't done a video on this yet and I want to make sure everyone is on the same page. That negative, when I pull it out, that's what's becoming the I. The 35 itself, we're keeping it inside just because 35 does not break down. Its only factors are 1 and 35 and then 5 and 7. None of those are perfect squares. So my final answer for this is going to be negative 7 plus or minus I root 35 all over 14. And that's why it says in the title that it has complex solutions, because the letter I is a complex number. That's what we're shooting for. So let's go through this again. One more example, and then I will let you guys loose in the wilds. So x equals opposite b plus or minus the square root of b squared minus 4 times A times C all over 2A, so 2 times 7. This isn't the same problem, is it? Did they do that to me twice? Oh, no they didn't. Well, close enough anyway. So let's see here. It's going to be 7 plus or minus 49 minus 84. Yeah, it's exactly the same thing. Isn't that funny? Isn't that funny? So we can already predict it from here. It will be 7 plus or minus negative 35 over, oops, that's supposed to be 14. So it equals 7 plus or minus I 35 over 14. Gosh darn these screen grabs for giving me the same numbers every time, even if all they do is change a sign. But I hope that this helps you. That's 4 more topics in your repertoire that you now know how to do. There are still several more videos because there's a lot of topics in Goal 4. I'll keep going until the cows come home, apparently. I will see you guys in the next video. Stay happy, stay healthy, stay safe.